In our previous video, we saw parallelograms having the same base and between the same two parallel lines. What was the relation between the areas of the two? Yes, they were equal. Will the relation between the areas be the same if one of them is a triangle? Let's see. But before that, we need to know something important. Let's have a look at this parallelogram PQRS. Let's draw any one of its diagonals. Say we draw diagonal PR. We can see that this diagonal has divided the parallelogram into two triangles, this one and this one. Here, triangle SPR and triangle QRP will be congruent. Yes, we know that the diagonals of a parallelogram divide the parallelogram into two triangles which are always congruent. It's always true. Even if we use this diagonal to divide the parallelogram, these two triangles will be congruent. Now, let's consider a parallelogram and a triangle having the same base and between the same two parallel lines. Let's see how their areas are related. Consider this parallelogram PQRS and triangle ASR having the same base SR and lying between the same two parallel lines SR and AQ. We first draw a segment parallel to side SA from the point R. We mark this point as point B. Now, this figure is divided into two parallelograms, this one and this one. Parallelogram ABRS and parallelogram PQRS. Look at the parallelogram ABRS carefully. Can we say that AR is the diagonal of the parallelogram? Yes, we surely can. And we know the property of the diagonal of the parallelogram, right? Yes, it divides the parallelogram into two congruent triangles. Hence, triangle ASR and triangle RBA are congruent. Now, look at the two parallelograms here. Can we say that the area of parallelogram PQRS equals the area of parallelogram ABRS? Yes, we can. The parallelograms on the same base between the same two parallels are equal in area. Now look at the area of parallelogram ABRS. Can we write the area of parallelogram ABRS as the sum of the areas of triangle ASR and triangle ABR? Why not? This entire area is the sum of this area plus this area. Now look at these two triangles, ASR and ABR. We know that they are congruent, right? And what do we know about the congruent triangles? Yes, that they are equal in area. So, we can say that area of triangle ASR equals the area of triangle ABR. So, we can replace area of triangle ABR with area of triangle ASR here. Now, can we write area of parallelogram ABRS as twice the area of triangle ASR? Yes, we surely can. And we also know that the area of parallelogram ABRS is equal to the area of parallelogram PQRS. So we get this relation. So what can we conclude from this? We conclude that if a triangle and a parallelogram are on the same base and are between the same two parallel lines, then the area of the parallelogram is equal to twice the area of the triangle.